Hello everyone, welcome back to the Maths Lab, where maths is diced and left with no crumbs. In the previous lesson, we learned how to find derivatives using first principle. While first principle helps us understand what differentiation really means, it can be quite long and time consuming. Today, I'm going to be introducing a much faster method called the power rule. By the end of this lesson, you'll be able to differentiate expression like 5x raised to power 3, 7x raised to power 8, and many more in just a few seconds. So let's get started. What is power rule? Consider a function of the form y is equals to ax raised to power n, where a is a constant, x is a variable, and n is the power. Now, the derivative of this function using the first principle is given by the y all over dx is equals to a n x, which is raised to power n minus 1. Now, don't worry if this look unfamiliar. Let's understand exactly what this rule is saying. So I am going to be explaining what the rule says, which is step 1, multiply the coefficient, which is the constant, by the power. Step 2, reduce the power by 1. That's all. Multiply by the power, reduce the power by 1. So let's look at an example. Example 1. We are going to be differentiating y is equals to 5x raised to power 3. The coefficients, constant slash coefficient, is 5. This is in the position of a. The variable is x. The power is 3. You can remember what we did up here. A is a constant or coefficient. Constant or coefficient. X is the variable and n is the power. So we're going to be following the step. The first step is to multiply the coefficient by the power, which is 5 times 3, which is equals to 15. The next step is to reduce the power by 1 as 3 minus 1, which is equals to 2. Therefore, the y dx is equals to 15x raised to power 2. Very simple. Example 2. Y is equals to 7x raised to power 5. The first step, multiply by the power, which is 7 times 5, which is equals to 35. The next step, reduce the power by 1, which is 5 minus 1 give 4. Therefore, the y, the x, is equals to 35 x raised to power 4. So what we have been doing basically is the y, the x is equals to 8, which is a constant or coefficient, times n, which is the power, x, n minus 1. This is basically what we're doing. A times the constant, x raised to power n minus 1, reducing the power by 1, multiplying the constant or coefficient by the power. So we're going to be taking another example. Example 3. Y is equals to minus 5x raised to power 9. Our minus 5 is the coefficient and 9 is the power. Step 1. Multiply the coefficient by the power, which will be minus 5 times 9, which is equals to 45. Next step is to reduce the power by 1, which will be 9 minus 1, which is equals to 8. Therefore, the y over the x is equals to, this will be minus 45. So this will be minus 45 x raised to power 8. So this is our dy dx of this equation. We'll be looking at another example. Example 4. Y is equals to 6x raised to power 2. First step, multiply the coefficients by the power, which is 6 times 2, which is equals to 12. Next step is to reduce the power by 1, which will be 2 minus 1 is equals to 1. Therefore, the y, the x is equals to 12x raised to power 1, which is same thing as 12x. Now it's your turn. Pause the video and differentiate. Y is equals to 6x raised to power 4. Give it a try. The solution is to multiply the coefficients by the power, which is 6 times 4 give us 24. And the next step is to reduce the power by 1, which is 4 minus 1 give us 3. Therefore, the y, the x is 24x raised to power 3. If you got that right, well done. Today we have learnt the power rule. One of the most important rules in differentiation. Remember this step? Multiply the coefficient by the power and reduce the power by 1. In the next lesson, we'll learn how to differentiate expression with more than one term using the sum and difference rule. If you found this video helpful, don't forget to like, subscribe, and share it with someone learning calculus. Thanks for watching, and I will see you in the next lesson. Bye!